Hello, and welcome to the January 17th, 2018 edition of the SIG cluster Lifecycle cluster API breakout meeting. I want to start today's meeting just doing follow-ups from last week's meeting. There was one action item that was assigned to Fang and myself, which was to schedule a design review meeting with the SAP folks that presented the node controller manager. That has been scheduled for next Monday at 10 a.m. Pacific time. If people were unavailable basically between now through Sunday, and that was sort of the first time that we could get together. If people would like to be invited, this is not meant to be sort of an exclusive meeting. It just was a time that worked for sort of the key stakeholders. Please let me know, and I will add you to the invite. Yeah, so I think that was the only thing that I wanted to follow up on from last week. Another sort of announcement, Jessica, thank you for adding this to the meeting notes. Yesterday, I had Paris create a Slack channel for us called #cluster_API in the Kubernetes Slack. This was after Joe Beta did his thank God it's Kubernetes talk last Friday on the cluster API. And during that talk, Chris Nova and I were chatting offline, and she asked a couple of questions like, where do people get together and talk about the cluster API? And I realized I didn't really have a good answer for her. And so I created a Slack channel so that we could get together there and talk about the cluster API. If people weren't following along closely, it turned out that a couple hours before Joe was starting, the code didn't actually build, and we were kind of scrambling around, chatting internally, trying to figure out what it had broken, and there was some weird GoDeps problem. But in response to that, I know there was like an issue filed and some emails sent around. And I think it was unclear if you didn't work at Google, sort of how that was being addressed or fixed. So I'm hoping that going forward, we can start doing those sorts of things in the Slack channels to provide greater visibility and also have more people be able to participate in finding and fixing problems. So next, Martin has a question about folder structure. Do you want to sort of explain what you're thinking about there?
Oh yeah, so if you look right now at the repositories, there are multiple clients that have generated, one from the extension API server that was just recently added, and one was the one that I previously generated. And for example, the extension API server also added blank types for the API. So I suggest we split. Just make the folder structure far more understandable, like with one folder only for the API, and that's only for the types. So later on we can just split them and one folder only for the client and etc. So it's far easier to understand and to have I don't have any redundancy.
If everybody agreed, we will eventually move from the custom resource definition to the API server. So the current extended API server will be replaced whole type definition and also all the generated code. I think when we finish all the migration from the current class API code to the extended API server, and we will rename the extended API server to the class API. So just avoiding the confusion. I think in the future it will be just only one copy of all the API type definition and the generated code. This just temporary.
Yeah, that was also my understanding, as this is just sort of a transient state as we're spinning up the aggregated API server. But you do bring up some good questions about what should go in the cluster API folder. I think there's pretty general agreement that the types should go in there. But I anticipate us having some, either shared libraries or even some shared, maybe a shared controller manager, skeleton, or something that we want to reuse across different implementations. And also the extension API server, where we're going to have other sort of buckets of shared code. And we should talk about whether we want that shared code to go in the cluster API folder, where that's like types and shared code, or where that should just be types to make it really small. And we use sort of other top level folders to put code that we think it's reusable into. I don't know if you have suggestions, Martin or Fang or anyone who sort of looks into this.
If we can mimic what right now the core Kubernetes is trying to do, just having like repositories or let's say folders for the different things. So they have for the API, for the API server, and etc. So they're trying to split up, because if we just bundle everything together, we'll have really bad dependency hell in the future. And if you try to import only the API, then you might get some other things that you don't want to use, and etc. So it's not very bad. It's not very good experience to bundle everything together.
I think API and the API server should be living in the same place, because they are tightly, it's shared, right? It's I think, but for the controller part, I think there will be many different implementation. So for that part, I think we can separate out. But I still think maybe for the controller manager part, there will be still some common code, like Robbie said, and when you think about maybe some skeleton code, or like something like common shared by all the different controller implementation. We don't need every controller to implement all the boilerplate code, right? It's just boring.
Yeah, I do think that Martin had a really good point, though, about importing the API types, because if we do bundle the aggregated API server with the API types, and another project wants to be a client of the cluster API, then they end up importing all of our sort of serving infrastructure for the API, when all they really care about is, I want to be able to have a client that knows how to talk to the API. And so I think, yeah, keeping that sort of separate, like maybe the cluster API directory is just the types effectively, so it's really easy to vendor elsewhere. And then we can put the aggregate API server, which we do believe will be reused by pretty much all the implementations, somewhere where everyone can easily get it. But if they're trying to implement the cluster API, but not necessarily to import for people who are trying to use the cluster API, to make it easy to build tools on top. And I think that's what Martin was trying to say, sort of following that pattern for the main repo.
Makes sense. Agree.
Again, everyone will need the client, which will actually depend on the types. So the only thing that at the end we care is the client. And I mean, for if you don't write anything, if you don't want to modify or fork the API server, you only need like the client, and the client will get that type. So this is more or less.
Okay, so looking at where we are today, Feng is in the middle of sort of transitioning stuff out of the CRDs into the extension API server. So I think what we should do is we should wait for that transition to finish. And maybe as part of that, he can also do this split, or we can loop back and we can see where the directory structure looks like once that's finished, and then make sure we kind of get it to the desired end state of having it be really easy just to grab the generated clients and the types. So I think what I would suggest is we circle back on this in a week or maybe 2 weeks, depending on how long it takes to extract the CRD code, and make sure that this is still headed in the right direction and looks good.
Sounds good to me.
All right, so next I put an agenda item for the machines pull request. So Jacob sent out this pull request quite a while back. He, at sort of at the same time, merged a version of the pull request so we could start writing code, left the pull request open for comments. It sort of gathered a whole bunch of comments in that time, which at this point we should resolve for a couple of reasons. One is that, unfortunately, Jacob has moved on to another project at Google, and he's now focusing his time on Istio. And so there's a pretty large burden for him to maintain that pull request open under his name, because this is not his primary job any longer. And the second is it would be nice to sort of get it merged to unblock making sort of Delta pull requests as people want to suggest mutations to the API, rather than having that centralized in one place. So Jacob sort of put a nice summary of where we were at on the pull request and steps forward from there. And then he also had a couple of things that I created new issues for. So we have 2 new issues that we should consider sort of fixing, if you will, in the Machines API. And then his proposal is basically 3 steps of someone going through and basically sanity checking the delta between what's checked in and what's in the pull request, and then getting this thing merged. So I just wanted to bring that up here, see if anybody wanted to volunteer for going through the types files and doing that sanity check. I've been planning to do it, but I haven't had time yet. So if someone wants to do that now, that would be awesome. And then also see if anybody else had any outstanding comments on this pull request they wanted to bring up in this forum versus filing issues or sending pull requests to modify the API once this pull request merges. Comments, thoughts?
So we have to check what's what's the actual representation in the repository and what's in the pull request, right? And try to modify the actual state with the pull request, or the other way around.
Sorry, I muted myself. Yeah, so what he wrote was basically he checked the file in a different place in the repository than what the pull request is for, so you could actually see the full API in the pull request and not a 0-line diff effectively. And so because we aren't actually seeing a diff, it's basically to go through and do that diff manually and make sure that the types in the pull request match the types that are checked in, and that any differences are what we want. Right, so he says that there's some differences, like what's in the pull requests. We're using like an enum type for a machine role instead of a string, and there are a couple other little ones. So yeah, if that's something that, Martin, if you're interested in sort of, I linked to the comment that he put on that PR talking about what steps he proposed, which I think makes sense. Yeah, if you wanted to read through that, and I think step 1 is the thing that we need someone to do, which is basically the sanity check.
Yeah, I'll do it. That's okay.
Excellent. So yeah, once you do that, just go ahead and update the pull request. I believe that I will get notified, and then we can LGTM and get that guy merged and get it off of Jacob's plate. So next thing I put on the agenda was the MachineSet pull request. So this was sent by the Lucy folks to add a MachineSet sort of sitting on top of the machine. I'm not sure if people have seen this, so I wanted it was sent out right before in the US what was a long holiday weekend. So I wanted to bring this up for people's attention so people could take a look and provide comments if they haven't seen it yet. And we hope to get some version of this merged within the next week or so people can start tinkering around trying to implement sets.
I have a comment. So I made the I already commented the pull request, but let's discuss it. So it's if you look at the current implementation of the stateful of the deployments in version 1, it's actually from version v1 beta 1 2, I believe, and there the selectors are immutable, so you cannot change them after you create them. So are we going to enforce this by default? Because if you're going to use it, then we have to change it, for example, for pointer and etc. But yeah, those are small details.
Okay. Yeah, I mean, I think one of our goals here should be to try and have consistency with other parts of the Kubernetes API, because then you have sort of the principle of least astonishment for people that are used to working with Kubernetes applications and replica sets. Then when they start working with machines, they behave very similarly. And so I think if there's a pattern that's been established in a replica set or deployment for how we handle label selectors, we should have a really, really good reason for not using exactly the same pattern. Right, so we should default to using the same pattern, or have a really sort of strong rationale about why that doesn't work for this use case. So yeah, if you've seen an inconsistency between what's done in core and what we're doing here, we should fix that to make us look more like core. And thanks for catching that. All right, so someone, I'm gonna jump to this last issue, or last agenda item next. Who's stuck in the API namespacing issue? Don't be shy.
That would be me.
Excellent. So what do you want to talk about, Chris?
This was the only remaining action item from the cluster API review. And I just wanted to call it out because I created the issue 27 days ago to enable broader discussion on it, and no one has commented on it. So I just wanted to bring it to people's attention.
So as I recall, this issue was created because we were talking about whether machines should be an unnamespaced resource, which means that they would sort of implicitly only apply to the cluster that they live in, or whether we should put machines in namespaces, which would allow the flexibility to have machines in a namespace represent machines in a different cluster as opposed to the cluster that you're in, or multiple namespaces could represent multiple other clusters.
Yes, and this also goes into a little more detail about should we adopt some conventions, like, say, the namespace cube system. Machines in there are reserved for like locally managed clusters, whereas every other namespace can be assumed to be remotely. Anyways, read through the issue. There are 3 options. You can propose more, but I just want to get a consensus on how we should approach this and close it out so we can move forward.
On our side, we had we were looking at this. We would love the flexibility to potentially have these namespaced. You know, and certainly they could be used just to manage local clusters as well. But it would be great to have the door open for both. I think, for our purposes, we're definitely going to need that sort of root cluster approach that we talked about before. But we're also talking about use cases where we might be using local clusters as well.
Yeah, so please definitely go put your thoughts on that. I hope to get it closed out this week, and if we can just all agree by the end of this week, I will say this is what we're going with, whichever one we all agree on, and we'll put a nail in this.
Okay, will do.
Okay, I'm going to add an agenda item to circle back to this next week and verify that we have been able to close it out, or maybe we can close it out during the meeting next week.
Yeah, and I'm going to go ahead and post a quick message in Slack too.
Cool, thanks. So next thing that I wanted to talk about was states for machines. So one thing that became clear as we were having some discussions last week was that we're sort of implicitly defining a model for sort of the life cycle of a machine as we build a machines API and start implementing that. And I think it's really important for us to not implicitly define the model, but to be explicit about what the life cycle of a machine looks like. And furthermore, to all agree on what that life cycle looks like so that it's consistent across environments. And in doing so, we should clearly document what we think the life cycle looks like, what the states are, what the state transitions are, what each state transition means, so that a user who's using the Machines API knows that if they're using it on AWS and then they switch to using it on GCP, tooling that they've written around it, where they're maybe delete a machine and they expect it to go through a certain set of states before it's gone, that behavior can be consistent across environments, and that tooling will be portable across environments. Because I see things right now where you have sort of 2 choices. If you delete a machine, the machine object can disappear immediately, and the reconciler can say, oh, it's not there, let me delete the cloud resource. Or it could go into like a terminating state, which I see in some other resources in Kubernetes, where it stays in the terminating state until the underlying resource has been removed, and then the machine resource gets removed. And I think it's going to be important for us to start codifying what the states are and exposing some of those states in the API itself. So first, I guess, comments, concerns, questions about sort of the high-level view here. I've got more detail that I can talk about in terms of some proposed states and state transitions, but I want to see what people think about the idea of having a consistent state machine that we apply across environments first.
Sounds like a great idea from my perspective. I'm curious to hear a sketch on the states.
All right. Well, I can jump into that unless other people have comments. Or Philip, do you want to say a couple words about this? Philip's from our Warsaw office and actually drew up a list of states and sent it to me this morning, which was awesome. So I can talk through it. I can just let him do it since he's here.
Yeah. So basically, the context. Sorry, can you hear me? Okay. So the context is that like I was working previously in the managed instance group team. So the current deployment of Kubernetes clusters in GCE runs on managed instance groups. So that's like the place I'm coming from. So the states that we think were useful from our point of view might be like a good starting point for this discussion, so that we try not to reinvent the solutions to similar problems, but maybe try to learn from the experience. Yes.
Okay, I guess I'll go through what some of those are. We sort of have a virtual state, which is new, which is something doesn't actually exist yet. Another virtual state, which is a tombstone, which is where everything sort of ends up. So if you think about the state diagram, you start at this new state and you end up at a tombstone state, and you go through sort of a number of transient states and steady states in between. Sort of the most common place where we expect people to be is in like a running or a serving state. Which is basically, things are working normally. The machine is part of the cluster. We're running pods on the machine. Like effectively, we are able to serve traffic from this machine, or everything is running properly. Another steady state that we expect to have is something like standby or drained, which is, you can imagine I have a cluster and I want to cordon a machine. So we can sort of explicitly represent that state of a machine being cordoned as a different state than serving. Or running, because this machine, while it's still part of the cluster, still has a kubelet. The kubelet is still reporting status. We are no longer able to schedule new things onto this machine using the default scheduler. And so I think that that is maybe useful to explicitly have be a different state in the system. And then you can say, if I want to get machines and see all the machines that are cordoned, that makes that really easy. We have a couple of states proposed that are, in my mind, maybe a little bit overlapping, which is stopped and suspended. And so this is, if you imagine a virtual machine, you can press a button in the console to stop the machine from running. Or if you have a physical machine, you could do a power off on that machine. The machine is still represented in the API. The fact that it is not actively reporting health status doesn't mean that we should necessarily delete it from the cluster, right? Which is something that we do today. But that it's still sort of represented, and we know that the machine still exists, like the physical virtual machine is still there. It's just not running right now. So we have sort of a stopped state and maybe also a suspended state. So those are sort of the steady states that we could think of from the start, which is, you start without a machine, you end up hopefully in this serving or running state where everything's working. Maybe you cordon, maybe you uncordon, maybe you stop and restart your machine. But generally, you're hopefully in sort of this serving state where everything is working properly. And then throughout the life cycle of going through these different states, there are lots of sort of transitionary states that you end up in between these sort of steady state places where we expect machines to be most of the time. So in particular, if you want to go from running to cordoned or drained, we have a state transition there where you go from running to draining to drained, right? So we can explicitly represent the fact that we are actively draining a machine. So draining means that you cordon the machine, you make it unschedulable, and then you start removing the pods that are running on that machine. And this can often take a while, right? So if you think about pods are able to set graceful timeouts so that when you, if you want to delete a pod from a machine, it can take quite a long time to do that. So you can end up in this draining state for a while. Like we don't expect this to be, you go to draining and then, a second later, you're in the drained state. Like you could be in draining for, hours, right? There's also a possibility to put a state sort of between running and draining, where we can ask the system, like, I want to drain this node, and the system can say no, right? We can rely on things like pod disruption budgets, where the system can say like, sorry, you can't actually drain that node right now, because if you were to drain that node, you would not be respecting the disruption budget for this pod that's running on that node. And the system can so basically bounce you back into the serving state by rejecting your request to start draining a node. Again, so if we have this notion of a stopped or a suspended state, we can imagine a transition from serving to stopped going through sort of a stopping phase, right? So you might drain your node and then start stopping your node before it ends up in the stop state, and vice versa. Going from stopped to serving, you might start your node again, undrain your node, verify that things are all working correctly, and then end up back in the serving state, right? So you can imagine, depending on the granularity that we want to sort of encode in the state machine, there being quite a few sort of transitionary states between what we think of as the steady states. Obviously, there's also a deleting state where you go from, my machine is either running or drained to I don't want it anymore. And so we put it into sort of a terminating state before it's actually removed. And then I think there's some other states that we've been thinking about where we might be trying to reconfigure a machine. So you might be taking a machine that's running and reconfigure that machine dynamically, and it comes back into the running state. Or maybe you drain it first and then you reconfigure the machine and then you put it back into the running state. So you can imagine maybe draining a machine, doing an operating system update, undraining a machine, and then it's back in the serving state. Or if you're able to do in-place upgrades for like the kubelet, say, or for the Docker engine, you might have a machine in the running state, and then you might just update it sort of in place, and it stays in the running state the whole time. So that's sort of a high-level overview. We started trying to draw this up in a picture. I didn't have time to render that before the meeting started, but I will try to post that publicly and link it into Slack later today, hopefully. And definitely we can talk through that pictorially next week. But I did want to sort of start the conversation, talk about some sort of states that we started thinking about, and see if there were sort of big gaps that people could identify in terms of other states that you think that the system might end up in that are missing, right? So I think that was sort of the impetus here is we want to, I think we want to agree on what the state machine looks like. We want to start agreeing on what the states look like and what the states mean, what the state transitions are, so we can start encoding that in the software, and the people that are using the API can depend upon those transitions. Okay, I've been talking a lot. I'm hoping some people have some comments.
Question about the draining cordon state. So isn't that more appropriate for the node itself rather than the machine? It seems that the machine is something that's physical, right? And there's states that goes through, but the node could tell you that it's draining, right, or that it's cordon. I don't think it necessarily needs to belong to the machine. Just an observation.
Yeah, I think part of that comes from sort of this a little bit of dissonance that we have between like the node and the machine are not the same object. They're two different objects. In an ideal world, if they were the same object, we had the desired state in the node object, then I think if you did say like, I want to drain this node, you'd put that in the desired state for the node, and it would be reflected sort of in the actual state. So one thing we should think about is whether we want to sort of maintain that sort of like, I desire my node to be drained, therefore I put it in the machine object and it gets reflected in the node object. Or if we think people are going to just kind of reach around and run kubectl cordon, and that it might be difficult to reflect the fact that a node is being cordoned in the machine's API.
And another thing to note is you might want to technically drain a machine because the node is malfunctioning and you can't rely on its status, and you want to go debug that.
So one more maybe argument for having this in the machine level. So once we would have like higher level controllers like machine deployment, then we will also want to track the number of machines that are not serving to be able to respect the disruption budget for the machines in the cluster. So for example, do not drain more than 2 machines at once. So it might be more natural to just be able to figure this out just from looking at machines instead of also going and looking at nodes.
Makes sense.
Yeah, but I think those are sort of exactly the types of questions that we want to have brought up, and sort of poke at the proposed states to make sure that they actually make sense, right? Because like Philip was saying, like we can sort of whiteboard and say like this is what we think it should look like, but until we actually sort of try to use it, and until we sort of get the input from everyone else that like, oh, there's not something big that we missed, or maybe this doesn't make sense, it's kind of hard to sort of vet that design. So I think that's part of why we want to talk about it here. And like I said, I apologize for not having a picture to present right now. I think that'd be a lot easier to talk to. And I will send that out, and we can definitely talk over it more next week. But I also wanted to start the conversation and not wait for the picture before putting this in people's minds so you can start thinking about it. All right. There's nothing else on the agenda. Does anybody else? Does anyone have anything else that they'd like to talk about today? Okay. So as Chris mentioned, please go take a look at the issue that he linked in the notes. We'd like to wrap that discussion up in the next week or so. We also want to wrap up the machines PR here pretty quickly and get a version of the MachineSet PR merged. So if you guys have some bandwidth, you have 25 minutes now because the meeting's ending early. Please go take a look at those issues and pull requests, and join us on Slack, and we'll continue discussing there between active meetings. Thanks everyone for coming. We'll see you guys again next week.